I have a feeling a lot of people are sick, so shout out to everyone who's sick. Thank you for staying home. Feel better soon. There's your homework. Notice that tomorrow's homework check is only going to go through 614. That was Fridays, so please make sure you're done 611 up through 614. We're shifting gears a little bit today. 621. Again. Now, what's different about the resource page that you have today? An equal sign in the middle, as opposed to what was the sign in the middle before? Question mark. So now we're going to say that we know the left side is the same as the right side. So when we get to using that, that's the nice thing about this resource page, is we know the left is the same as the right. So anyone want to read for us, or are you going to have to listen to me? Why what?
The little thing, it has like a little mute sign and a little red S.
Mute? What? Where?
Okay. Oh, or I'm just seeing this.
What are you? That means that it won't grab the sound from my computer. So my computer makes like a ding or a click or whatever. So that means like it's not getting this sound. But the microphone means it is getting me. Watch. See it? It goes gray and then it goes black. That's how you know it is recording. All right. So Grant, you want to read?
In the last section, you figured out how to determine what values of x make one expression greater than the other. In this lesson, you will study what can be learned about x when two expressions are equal. As you work today, focus on these questions. What is both sides of it? Is there more than one way to simplify? What value of x will make the expressions equal?
Love it. You might have a career in radio someday. All right, so 648, if you want to label your notes, 648. I really, like, true confessions, someday want to own a bowling alley. Like, I love bowling.
That's a weird dream.
It's an aspiration more so than like a dream. So maybe someday you guys will be coming to, Hudson Lanes. But Sandeep works at a bowling alley that currently charges players $3 to rent shoes, $4 per game. His manager is thinking about charging $11 to rent shoes, but only $2 per game. So more expensive for the shoes, cheaper for the games. Now, you can't bring your own shoes. That's normally a question that we think about first. Do I have to pay for shoe rental? Yes, that's a lot of how they make their money, right? So, I want you and your partners to think this through. If a customer rents shoes and plays 2 games, which pricing model would be better? And if they bowl 7 games, which pricing model would be better for the customer? So take a moment, think, how could you figure this out? Use whatever strategies you can. We're not really using that resource page yet, because we don't know that these are equal. Actually, I highly doubt that these will be equal, because the pricing models are so different. What's up? Nice glasses. I like this.
I know this sounds weird, but can't you bring your own bowling shoes?
Can't. Not at this bowling alley. They don't trust your feet. I don't know. But there are, you could, but a lot of times, if they want to make their money that way, most people don't have their own bowling shoes, right? I almost went bowling last night with my brother and his little from Big Brothers Big Sisters, but he bailed on us. I think it was his girlfriend. No joke. I'm not making this stuff up. I was supposed to go bowling, and Mikey bailed on us.
Oh, dear Mikey.
I know.
Mikey. Sure.
We got Chinese instead.
Oh, all right.
Yeah, that's okay.
All right, work with your partner, figure out what would be the price of each pricing model for 2 games, and what would be the price for each of the 7. Use this for class and the This weekend was really bad, dude. I was at Matt Counts and then at the play, and I was way too busy to come back over here. right, Ella. If I am going to figure out the pricing of 2 games and shoe rentals under the old model, how do I do it? So $3 times the 2 games that we play. There we go. Sorry, that box is telling me. And then add $4 for the shoe rental, right? So order of operations, do your multiplication first. What's 3 times 2? 6 plus 4. We would pay $10 under the old model. Can anyone say anything automatically? Nope.
Are the shoes like $3 in the game?
Did I rent 2 pairs of shoes?
No.
So be careful when you pull your numbers down. This is not right. What do I need to do? Switch the 3 and the 4, right? The 4 is every game. Right, so the 4 happens twice. How many times do you rent shoes? Only once. How does that change my answer? It's actually 11. Be careful when you set that up, guys. It's easy to... Now, as Al gave that to me, I was totally fine to write that up there backwards because it's good practice to show you how easy it is to get those switched around. Ask yourself when you're setting these up, what happens multiple times that will end up getting multiplied. We may not always know what it gets multiplied by, but it's going to get multiplied.
You didn't put the unit for 11.
Thank you very much, sir. On the new pricing model, under the new pricing model, then Emma, how would we set that up? What happens multiple times? What happens once?
11 plus 2 times 2.
So Emma said, well, I'm going to rent my shoes first and then pay for my 2 games. What's 2 times 2? 4 plus 11. So which model would you prefer? The old one, right? It's cheaper. If you haven't done so yet, try B. If you get done with that, you can move on to the next problem. But B is these 7 games. We're going to hang out there for a long time. Maybe it's a snow day. We're going to play a lot of games. Bless you. I don't even think I'm going to call people for this. So now, instead of 4 times 2 for playing 2 games, we have 4 times 7 for playing 7 games, right? $4 per game. What's 4 times 7? 28 plus 3. 2 times 7? 14 plus 11. Ooh. Delaney, can you make a statement for me comparing 2 games versus 7 games, the old model to the new model? Like, what could we say here?
The new model's cheaper and the old
Is the new model always cheaper?
Yeah.
Darn. So you can't just say the new model's cheaper. The new model's cheaper when what? When we buy more games. So, would there be a point where it wouldn't matter, like new model versus old model, like it'd be the same price for the same number of games? Do you think that might exist? Like where the new model and the old model, like these end results would come out the same. Like, do you think that could happen? Maybe. I'd give it at least a maybe. Interesting. Does everyone understand or like agree with what Delaney said? The new model is cheaper when you play more games. But if you're going to play not very many games, the old model is better. Cool with that? So let's keep thinking about this. If we then get told, and we're going to keep working on this, we get told that we can write the original and the new like that. Now, what is the X here? It tells you. What does X represent? Games, right? Number of games we play. We just plug it in and then we can find our cost or whatever. So if you're going to use the algebra mat, if you're a tangible person, go ahead and grab these tiles. 4 X's plus 3 on the left-hand side. Now, you might not have enough ones. Everybody at your group probably won't be able to do this because this 11, that might be tough to set up. Go ahead and build that. Now you could use at least one 5 tile on the right side probably. So I have a 5 tile there at the top of mine. And I'm actually going to drag mine up onto the TV. But those of you watching at home, this is how we would start. Alright, so the book already showed us how to do this. I'm going to organize some things. I'm going to put my variables at the top part and my ones at the bottom part. Can anyone tell me what you think I should do? Start simplifying this. Remember our rules of balance. You do one thing one place, you got to do it the other place. Grant, what are you feeling?
Take away 2x.
Take away 2x from each? I like it. What sort of, like, what rule are you referring back to that lets you do that? Balanced pairs. So, first thing that I want to ask, but it's kind of the gimme question, are there any 0 pairs? Are there any opposites up here? No, we don't see any red tiles. Right? We have no red tiles, no 0 pairs. So, Grant says, I can make balanced pairs by doing the same thing on both sides. So, up on the TV, I'm taking 1x away from both of these. Another x away from both of these. Kept it balanced, I did the same thing. Now, what else? Somebody different. Kate? Ooh, these 3 1s we can take away. And these 3 1s we can take away. Which now we get left with what we see here in part... I don't even know what that refers to. Part B, part C, something like that. So we now have 2 x's. And over here, I'm going to replace my 5 tile with some 1s just to make life easier. So there's 5 1s. What do we have on the right-hand side? 8. Now, I need everybody in your notes real quick. Actually, don't draw it yet. I'm going a little bit rogue. So we have what they have up there, or you can look on the TV. We have 2 x's equal to 8. And by the way, we're using our equal mat. We're forcing this to be equal. Notice that they're using their question mark mat. They're asking the question, will they be equal? We're kind of forcing it, which, because we know how to utilize math, we can kind of make things fit. Now, what happens if x comes out to be a decimal? Like, so we're forcing this, right? What if we get an answer? We don't know our answer yet, quote unquote. I know some of you sitting there do know your answer. What if I got like 2.7? Or 3.64, or something awkward. Could I play that many games? No. So what would a decimal answer really tell me? Who are you looking for there?
I'm sorry to interrupt you.
You're good.
Abby Finley.
Did you guys see Abby this morning? Did anyone see that? Francesca's here. Yeah, Spanish. I don't know about Abby. I'm not sure.
Abby was
Abby wasn't still not here. So I think Abby's still gone, but Francesca's here. You're good. Decimal answer. If I can't play 3.6 teams or 1.74, like a decimal answer wouldn't actually be able to happen. We can force it with the math, but it wouldn't actually be true. So if you're at 2x is equal to 8. I want only a single x. So I can just take this x away from here, right? Who can tell me why I can't? Somebody new. Somebody I haven't talked with yet. Aubrey, why can't I take this? I can't do it over here. There's no x left to get rid of. How could I only look at one of my x's? Alex? So, physically, and we're going to draw this in our notes, split, okay, I'm going to put half up here, half down there, like half of what I have on the side. So, 1 up, 1 down, 1 up, 1 down, 1 up, 1 down, 1 up, 1 down. So, I'm thinking effectively like I'm splitting my mat and saying, okay, if I only look at one of the x's, what is it equal to? 4. So we now get that x equals 4 if we use those rules that we know. So Sandeep got to here, but then he asked, is x equals 6 a solution here? Excuse me. So we got, and let's give you a second, in your notes, please really quickly draw that you have your mat. These are equal to each other. And then just make an easy drawing showing that if you have 2 x's over here, you can put one on top and one on bottom. Split the whole mat. And we made that equal to the 4 and the 4. So really this says 2x equals 8. Or x equals 4. Let's draw that real quick. So Sandeep wonders, okay, so 4 games works. So 6 games works. Okay.
No, because that would be 6 equals 4.
Yeah, so if we found out the answer is 4, and Sandeep's saying, like, well, can it be 6? Well, no, because 6 isn't 4. Now, how do we prove it to him, though? He's still like, but I think it would work. Maybe he thinks we made a mistake. Maybe Sandeep's like, dude, I think I'm better at you, or better than you at math. Well, I mean, how do we prove it to him? We need evidence, right? We have to support claims with evidence. How do you check? All right, I'll flip the question. How do we prove to Sandeep that our answer actually does work? Okay, use the how. Give me hands, because I feel like multiple people kind of want to answer. Grant? You mean give him a problem? We already have a situation. But I want to check the one I have. Guys, this is kind of concerning for me, so I need everybody in your notes to write check. The way that we check an answer that we found is test, does it actually work? So what we had to start was, what, 4x plus 4x plus 3, right? $4 per game, $3 for shoes, and $2 per game, $11 for shoes. We could actually use G for our variable if that would be easier for you to remember that that means games. What are we checking? What did we say that we think makes this true? What did we say X should be to make this true? So to check, all we do
is replace x with 4. So this now turns into 4 times 4 plus 3. And this turns into 2 times 4 plus 11. We said x is 4, right? So if we make x 4, what should happen? The left and right side should come out to do the same thing. What's 4 times 4? Plus 3. 2 times 4? Plus 11. Hey-ho. We made it work. Does that make sense? Give me a thumb scale. Where are we at? Good, kind of okay, or like, no, I just don't want to ask a question. You're milking a cow. Do you ever play euchre? You know, play euchre? Do you know what I mean? If you get in the barn and you gotta like milk the cow.
Oh, yeah.
So, dangerous question. We already talked to Matt. How could I prove to Sandeep x can't be 6? Instead of plugging in what we got for the x, we could plug in what Sandeep got for x and show him that it wouldn't work. And if you test it, I'm not going to make you guys do it, but if you plug in 6, this is not true. They would not be equal. I mean, Valentine's Day is coming up, so who knows? All right, try this with your partner. Whether you use tiles or not, I'm not concerned about. Some of you are more geometric. You want to see the tiles. Some of you are more algebraic. You can write it out, whichever way you want to take. Set this up. What are the empty tiles again? Negatives. So take a few minutes. Try to figure out what x could be here to make this true. We good? Okay, so I am pulling this out. Using this with you. However, the only way that algebra would help you is you understand the algebraic process. So if you understand how to use algebra, you don't need this. You don't need to use all of that on one. This is to help you understand why. So if I take something physically off, imagine that missing no balances. So imagine somebody is crazy. He pulled out a giant balance. Right? And he pulled up other things that represent games. If I remove something from one side of it, it's going to be off balance unless I remove the same thing.
You have to figure out how many times
Don't take this thing.
it's like so many answers, only like a billion, I'm 6.
So I set that up. I turn on the board, set that up on
Figure out. It took this thing way longer
to solve that. I'll never again ask you. What is it you need to understand algebra?
I tried 6, that'd be 12. One that tried 1 plus
I mean, have you ever played Fallout? How do you carry out yourself in Fallout? That backpack has to be huge.
Yeah, man.
That backpack must be like a TARDIS.
What's it called? The after, like the mobile app thing, or like the
All right, let's imagine we had this on our mat. Now, Annika, I'm not just picking on you because you were just cracking up, but your card just came up.
what could I do if we had this physically on our mat?
What would be the first thing that you could do to simplify?
Oh,
Hey, calm down. That was really rude.
sorry. I just messed up.
Oh, so you're come on yourself?
Yes.
Okay, I thought you were okay. That's fine. What kind of pairs? Pairs that cancel are called what? They make what together?
Zero pairs! So, if we look for zero pairs, we have those here, and we have those there. But algebraically, if you don't want to do it on the sheet, all we did was the addition. So Zoe, I'm pointing at you because you said you don't want to take the algebra mat with you to the bowling alley. You got to understand the algebra then. So, we now end up with 3x plus 1 equal to a 1x plus 5. So I'll just keep doing this thing. All right, Zoe. What else could I do? You can either tell me on the mat or just what you would do in the equation process. Yeah, take away one of the x's from each side. So here, that would be removed. What kind of pairing is that when it's from both sides? Starts with a B. Balanced pairs. We're keeping it balanced. Remember, Sandy brings in that whole balance scale thing. Guys, look, I can show you. Did I? Okay. Have I shown the... We watched the Monty Python like she's a witch thing, right? Okay. Let's try to wrap class in the next 10 minutes, and I have a video about balance scale where Monty Python, which is this like British comedy troupe, proves that a woman's a witch based off a balance scale.
I mean, weird. You know what? Something else on the other side. Yeah, she's a witch.
All right. Now, Emily, what could I do? I just took an X off each side. Yeah, we can take a 1 off each side. Please make sure you're writing the algebra. You can't just do it on the mat. You got to start to understand how to write all this and show your work. This is what I'll be looking for on the mini mastery later this week. Hint, hint, nudge, nudge. Mini mastery later this week. 2x now equals quattro, which now, just like we did before, if you had 2 x's over here and 4 over here, top, bottom, we'd end up with x equal to 2. And the work that we would show is that we divided by 2 and divided by 2. We split them into 2 groups so that each group would just have a single x. Does this? Better question. Any questions on this process? Now give me the pencil. Now that we did nothing. On Alan's end. Are you ever going to get a haircut? Well, both of you. You're both getting pros.
I'm getting one this week.
All right.
I mean, I
I like it. You got to start picking it out, though. Design.
oh,
Try this one. I think you guys are getting better. Try this one. Well, I mean, it's not like, well, I mean, Nathan could, but it doesn't do as much. Different hair. Nathan's walking around with a hair pick. Because we should all be at this point, Aubrey, tell me what's on the left side and the right side, just starting out. Like these? So we're going to try to not build this, actually. I'm going to say don't build this on your algebra mat. We're going to try to just write this all out. We have positive 2x's, and we have a negative x, and we have a 1 and a negative 1, right? Kind of awkward that there's so many positive, negative, but we'll deal with that in a moment.
What's on the right side, Kate?
Positive 1x plus negative plus 3 plus negative 30.
Ooh. Okay. Now, I like to show my work when I'm doing the math of something, if they're close to each other, if it's easy enough. I just show, all right, I can add these guys. I can add these guys, right? I can make some 0 pairs. I can make some 0 pairs here. Make some 0 pairs there. So, if I have 2x and I take away an x, what do I have on the left side? 1x left. I had positive 1, and I pair it with a negative 1. Okay, that destroys. Positive x, negative x. Okay. Positive 3, negative 3. Okay. X is nothing?
But then that means x is nothing. But x is positive.
So, how do we check this? Plug it in, see if it works. If these are all 0, well, what? Wait, negative 0? What's the opposite of 0? Still 0. 0 is neither positive or negative, so the opposite of it is itself. Does that mean what? There's no such thing. It's the opposite of 0 is 0.
What's the opposite of 0?
All right.
Doesn't make sense. Doesn't make sense though, because if it's because on the thing it says shaded equals positive. If it's one shaded left and 0 is technically
X, the value of X is 0. So that shaded X tile is 0. So really it doesn't exist.
Okay.
Hey, so Patrick's having like the mind explosion. What they're essentially telling us there then is that these tiles are a figment of our imagination. These X's do not actually exist. They are all 0s. We are all crazy.
Yeah, totally simple.
No, because I also got people not even taking notes at all. So write this out. 2x plus 2 plus negative 3. 5x plus 8. Solve it. Make 0 pairs if you can, which really just means do the math. Do balanced pairs. You do not have to draw it if you don't want to. If you understand the algebra.
Go with your signal.
Negative 1. No. It's like, it's like a block.
It keeps it really hot in that thing. And I don't like my coffee that hot.
And then this is like 2x. No, sorry. 3x.
Penelope.
One for here and one here.
What happens when I combine these, since they're like terms?
You get 1. Negative 1.
There you go. You get negative 1.
Then, Nathan, what do we want to do? So we made all our 0 pairs. There's no more opposites. So now we got to do balanced pairs. We got to do the same thing on both sides. No, it's past it. Or you can ask Alan for help. You guys got it? And then move on. Allie, do you know what we do on both sides? So we want to start getting rid of things that we have extras of. Or not, do you know? I'm going through cards. So, Allie, if you didn't know, you should be asking or conferring with Nod. She knows, right? She just told me.
You guys need to be using your partnerships. If we take away this 2x, that means there will be no x's left over there, which is what I want. I take away 2 x's from there, add a negative 1 over here, equal to 3x plus 8. We then, Alan, coming back to you because your card. This is now the side that my x's are on, which means I want to get rid of these 1 tiles, right? Because I have these x tiles, I want to get x by itself. How do I get rid of these 1 tiles? How do I turn 8 into 0? Yeah, subtract 8, exactly. That's all we gotta do. So if we subtract 8 on both sides, that's taking away those 8 tiles. But over here, I don't have any positives to take away, so I essentially bring in negatives, and I end up with 3x equaling 9 negative tiles. Now, if you can't take something away, you're putting in the opposite. Then, how many groups of x do I have, and what do I need to do, Eleanor? I divide by 3 to turn that into a group of a single x, and x is what? Close. Negative 3. Watch that signage. We're out of time. Thank you guys very much. Maybe at some point this week I'll get a chance to show you that video. Nathan and Francesca, real quick, please. If you're going to